In our previous video, we have studied examples with one or two lone pairs. We will continue with that. Here we have four atoms around the central atom, and there is one lone pair. Example: sulfur tetrafluoride. So there is one lone pair on the sulfur atom. Considering the bonded pair and the lone pair, the electron geometry will be trigonal bipyramidal. So two fluorine atoms and one lone pair is making the triangle, and the other two fluorine atoms are on the equatorial position, and that makes the electron geometry as trigonal bipyramidal. You have two pyramids there, one above the plane and the other below the plane. To find out the molecular geometry, we just ignore this lone pair, consider only the bonded pair, and what we see, a seesaw geometry. So molecular geometry of compounds or molecules where we have four atoms and one lone pair around the central atom will be seesaw. Next one is four atoms but two electron pairs around the central atom. That is our next category. Here we have example of xenon tetrafluoride. Xenon tetrafluoride. Considering both the bonded pair and the lone pair, we see that it is making a electron geometry of square bipyramidal. So the four fluorine atoms are arranged in one plane. They are arranged in one plane, and the lone pairs are on equatorial position. This is also referred to as octahedral. So it has an electron geometry of octahedral. Whereas whereas um, its molecular geometry by ignoring the lone pairs will be square planar. All the four fluorine atoms in the same plane, so it will be square planar. The next one is where we have five atoms and one electron pair around the central atom. So we have example of bromine tetrafluoride, sorry, pentafluoride. So considering all the bonded pairs and the lone pairs, the geometry will be octahedral. And if we ignore the lone pairs to get the molecular geometry, then the geometry will be square pyramid, as you can clearly see in the image here. The molecular geometry will be square pyramid.